I'm Navin. I'll be doing a talk today. The title is Bespoke LLM Architectures for a K8s World, which is a very fancy way of saying like 101 things I learned about LLMs in K8s. When you get started, yeah, just a quick intro about me. I'm Navin. I go by Mad Max online. I'm a founding engineer at Opsverse. I've been working with, I did my master's in deep learning back before it was cool. Uh, yeah, I'm a Pythonista by nature, strongly believe in open sourcing everything. And anyone has any questions, any feedback, just want to hit me up on any of these topics or want to share in why Man United sucks as a football club, Naveen Pai is the place to do that. So a quick note about Opsverse. At Opsverse, we're the basic idea of Opsverse is to like build out open source based stacks. So what we do is we take out of the box open source tools and then build them into stacks and then sell them to enterprises and make money out of it. Now, the reason why we believe that adds value is because like lots of companies, they actually spend a lot of time trying to manage open source per se, and I think Evan is in the same kind of space where it's like, you have open source, but you don't really want to manage it, so leave it onto us and we take care of it entirely for you. So like we have a few stacks that we have today. We have Observe now that's based on observability. We have had a bunch of talks on observability, so a bunch of the tools that people spoke about are actually part of the stack out of the box. We have Deploy now, which is kind of entirely around the deployment stack, which goes from everything from getting your git push origin master to right up to wherever you're deploying your code. Then yeah, we do have like manage backstage and manage postdoc. Now, as you would expect, like manage backstage is kind of building up towards like a developer experience stack, and manage postdoc is building towards a product analytics stack. And on the side, like because we have like a bunch of this data and we integrated quite deeply into a lot of our customer stacks, we thought it would be good to like actually start experimenting a little bit more with LLMs, and like this is primarily what we'll be talking about today. So we have a product called Aiden, and Aiden is a very, very bad pun. It stands for AI DevOps engineer, if you would believe that. Yeah, but it's a DevOps copilot that we're trying to build out for mostly helping with DevOps workflows. So whether it's like a build, deploy, debug kind of workflow, or to like be an internal knowledge base that's tied into your own stack, or like, and yeah, it obviously learns from your environment, right? It's not like using ChatGPT and like typing in some data and getting a very generic answer. Like Aiden, the aim with Aiden is to like give you answers that are like much more specific to your issues in your stack, in your environment, based on your history, right? So yeah, we'll quickly get into the agenda. Yeah, before I get into that, right, like this is kind of what I will be speaking about. We have a very brief history of nearly everything in the LLM space. Then we'll talk about an evolution of an LLM app. And while we are talking about this, we'll actually dig a little bit deeper into Kubernetes and why we made the choice to like choose Kubernetes as the environment where we run some of these applications and some of these other training modules. Then obviously, right, I know that there's a lot of fans here who have this Kubernetes for everything kind of attitude, but like there are lots of places where I think Kubernetes does not really make sense, so we'll talk a little bit about that as well. And then obviously what next, right? So before we get started, just to get a sense of the room, right? How many folks here have used ChatGPT? Okay, if there's people who's not raised their hands, yeah, I really don't know what you've been doing for the last year. Anyone who's used any LLM other than ChatGPT? Okay, anyone who's built an LLM app? We spoke yesterday. I think we had an open space yesterday where we spoke about, I think all of the people here were, who raised their hands now were part of that as well. Okay, so that's cool. In that case, I think we'll actually spend some time on the brief history of like some of this stuff, and then dig deeper into like the rest of it. Disclaimer, yeah, this talk is extremely opinionated and very loosely prescriptive. This is a disclaimer I had because I do not in any way claim to be an expert in LLMs. I did my master's in deep learning, but that's before the LLM craze started. But yeah, like a lot of these things are things that have worked for us within our context, and we'll talk about a little more about the context. And so a lot of places, there is an implicit it depends within this talk, right? Where we're gonna talk, it's like, we did this, you need not, but I'm hoping that with this talk, you'll be able to like figure out some of the trade-offs that we had to make when we are talking about some of these things. And yeah, obviously, they're all strong opinions, but they're quite weakly held, so at any point of time, if anyone feels that there are like anything that I've said does not make sense or has differing opinions, right? I'm happy to chat right after the conference or on Twitter where we can have like a conversation about this. And yeah, your mileage may vary, right? Cool. So let's start off with the history, right? How many people know of this paper? Attention is all we need. All you need, sorry. Okay, like folks, again, the same folks have like worked with LLMs kind of know this paper. This paper is kind of what started the whole LLM craze, right? So attention is all you need comes from a bunch of really, really smart guys from Google Brain. And they basically came up with this mechanism called attention, where, and this paper they spoke about this mechanism called attention, where what it's basically trying to say is like, how do you make sure that a language model that you have is able to pick up context over a longer span, right? So what that means is that if you give it a block of text, how can you like actually have data that it's generating while it's also keeping track of previous context? And that has been kind of the golden goose of like LLMs in general, language models in general, because it has always been possible for us to like create using Markov models or Markov chains. If you have done it in college, you can generate text, right? But that text is like not really contextual in any way. But with this paper, what these guys came out with is a way to like manage context, right? And that kind of changed the world. Now this paper came out in 2017, and like right now, if you look at all the authors of this paper, all of them are at different companies. All of them have left Google. I think between them, they've raised about like $10 billion, I think, primarily around like OpenAI, which is Kaiser on the right. And everyone's at different companies right now, all around the LLM space, more or less. Which is like a nice thing to say that, yeah, research doesn't make you money. If you want to make money, go and start a company. So yeah, once this paper came out, then you had these implementations that start coming on. So the first famous implementation, I kind of grouped them together as like BERT and GPT-1 and 2. They were, now when you talk about it, you'll call them like smaller LLMs, but back then they were like state of the art, right? So these had about 50 million to 1 billion parameters, and immediately like people started noticing that like if you have like small enough niche tasks, then like these can actually perform. They started beating state of the art records quite well. There still weren't human capabilities in many cases, but yeah, like it was really nice. It made really cool demos. Lots of people played around with BERT. Even at like, yeah, even lots of tech companies also started playing around with BERT for any sort of generation kind of task that they were working on. Right after that came this phase where we moved like by a factor of 10. So you came to GPT-3, GPT 3.5, Claude if you're used from Anthropic, and Google also has Lambda. And a common trend you'll see across this entire slide is like all of them coming up with like really weird looking acronyms. So Lambda actually stands for Language Model for Dialogue Applications. And it's very obvious, many cases it's like the acronym comes first and then you fill it out later, kind of like how Indian political parties do it, right? Yeah, but the nice thing about like GPT-3, 3.5, Claude Lambda is they ended up being like much more general purpose, right? And this is kind of when people started talking about things like, hey, like let's have a big enough model and let's dump it with as much data as possible, and maybe it'll be generic, right? Maybe it'll be a general purpose language model. And with like GPT-3, 3.5, Claude, Lambda, you kind of got to that point where it actually was proving to be pretty much true, right? And then yeah, you came to GPT-4, and just like the current world where we are at, again, it's a factor of 10 more, so it goes from about 200 billion parameters to about 1 trillion parameters now. Very Skynet-like in many ways. Some cases, yeah, like I'm sure like anyone with access to GPT 3.5 or 4 has like tried to like trick it with like some sort of puzzle, some sort of math problem, some sort of like, yeah, like people who in the know, right, an AI problem, and like try to see if it can figure out the answer. And yeah, in many cases, it's surprising that despite being what many people call a stochastic parrot, because basically what an LLM is doing is it's just using previous context to figure out what the next word should be, right? It's not doing anything much smarter than that, so to speak. But still, even with that quote-unquote simple model, it's actually able to like shock a lot of people and a lot of use cases, right? And then yeah, like we are at the stage now where GPT-4, when OpenAI came out with it, they were very secretive in terms of like what they use for training, how big the model is, how big the like what is the exact methodology that they use, where have they scraped data from, and they said it's for security of LLMs or something like that, which is like basic corporate talk. But it's expected like from some internal folks, some like hearsay within the industry that GPT-4 is trained on like 1.75 trillion parameters, right? So that's again a factor of 10. And there's other people who like talk about GPT-4 being an ensemble of 8 different LLMs, right? So what that means is that this is a common thing that people use, and especially people who are on Kaggle or any of these like data platforms, they kind of do this where they'll have like one model here and they have one model here, and both of them agree on something and they come up with an answer, right? So like there's an internal this that talks about GPT-4 actually not being one model, but it's actually 8 different models that are working in parallel to come out with an answer, right? And 8 different models that are trained slightly differently, still mostly generic, but they come out with something like this, right? So yeah, like this is kind of where we are at. Just recently, there's been talk of like GPT-5, where if you continue with the 10x kind of trend, then you would expect it to be 17 trillion parameters, which is a lot. Okay, it's 17 trillion parameters, which is going to be quite a bit. And then yeah, one can only guess like how much more it'll be able to accomplish. And while all that is happening in the proprietary world, we have like obviously this open source movement that's been going on in parallel, where you have like open source models. And I use open source in quotes because they are open source to varying degrees. In some cases, it's open source in the sense that you have a model that you can use for commercial purposes, or you can use it for your personal use without having to pay anyone. But it's not really, you don't really know what it's trained on, and you can't really build it yourself even if you have all the resources in the world. And obviously, to train an LLM like this, a foundational model, is going to take a lot of resources, right? But some of them are like actually a little bit more on the open source spectrum, where they actually let you know what the data is, how you can build it up your own. And they're like, yeah, if you have $5 million, you can go and follow this process, and you'll have more or less the same model, right? Just talking about open LLMs for a bit, because this is something that we'll be talking about more as well. Hugging Face actually has an open LLM leaderboard where they basically do stats around like how well different open LLMs are performing across different human tasks, right? And they have a bunch of benchmarks, and they compare them on these different benchmarks. And some of these are like reasoning, some of these are around like text generation, some of these may be around code, some of these may be around this. So what it's kind of allowing you to do is like at once see what the state of the art is for different use cases, right? And what that allows people to do is like pick and choose the LLM that you want to use for depending on your use case, right? And that matters a little bit more as we go ahead. So yeah, let's build an LLM-based application, right? And this, I'm sure, has been said at every single company in Bangalore, every single company in San Francisco, every single company across the world pretty much in the last year or so. So now, when you talk about an LLM application, right, there's going to be like different steps that more or less everyone will go through, right? So let's actually walk through those steps, right? Oh, but yeah, first things first, yeah, if you're doing something, if you're building an LLM app, you have to have a .ai domain. So yeah, we have something fancy .ai as our domain. That's the most important bit. Everything else is secondary. And then you start off, right? And this is kind of the numbers that I have there, 75% or whatever, and you'll see those numbers getting smaller and smaller. It's basically about how most companies like start building out applications and where they stop, right? It's a stopping point for them. Most of them will go through the same journey. So 75% get to this point and they're like, yeah, this works well enough, I'm happy with it, right? And the OpenAI wrappers, as I call them, all they're basically doing is they have like some sort of a prompt. And if you've been on Twitter for any time over the last year, you've seen a lot of these chats about prompt engineering, right? So a lot of these applications, all they are is it's going to be like a OpenAI prompt. And it's something like that. It's going to be like you are an expert at performing something fancy. The following is a question you need to answer. Be concise, right? And it's the way LLM works. It's very weird sometimes because it's been shown in papers that like adding things like be concise actually makes the answer concise, right? Which again, how does it understand? That quote unquote understanding is always a question mark. Yeah. So and initially, when the first wave of LLM apps came out, I know there are people who had like Naval bot, right? Answer this question like Naval, or like answer a question like this. Or answer a question like it's Bhagavad Gita or your Shri Krishna from the Bhagavad Gita. All of them are basically just this, right? They weren't doing anything special. They basically said, yeah, you are so-and-so from the Mahabharata, answer this question as per that person. It sounds very silly, but it actually gets, because it's a more generic sort of LLM that you have with OpenAI, it actually does quite well for, and can perform decent results, right? So then we get to RAG, right? RAG is retrieval augmented generation, right? Now the problem with the first flow that we had with OpenAI wrappers is that you're entirely depending on the LLM for the data output that you're getting, right? Now that is problematic primarily because A, the data that is there in OpenAI has a cutoff date. So if you want anything newer than that, it's going to be really hard for you to get. So for example, it's impossible for you to like find things about your company, for example, that internal data if you want, or you ask who won in the match between India and Pakistan day before yesterday, right? There's no way for it to know. But with RAG, what it allows you to do is like you have a vector database, and what you do is like anytime anyone asks you a question, you go to the vector database, get a bunch of documents that match in similarity to what the query that is being asked, and you pass that along with your context when you're making a query to OpenAI. The reason this is helpful is because like this cuts down on hallucinations by a lot, right? By a lot, because you're basically telling OpenAI that don't come up with your own answers, use the context that I'm giving you to figure out the answer, right? And that kind of, for a lot of use cases, like if you see between the first 75% and this 15%, you kind of get to 90-ish%, right, of apps. Because I think RAG is kind of a really good stopping point for most applications that people are using. And what vector databases are doing is very simple, right? They basically take your documents and or whatever data that you have, chunk it into smaller bits, and create a vector representation of it, and store it in the database. And then anytime you're making a query, all that you're doing is you're going to the vector database and saying like, give me the vectors that are closest to the vector that I'm providing you, right? In this question, it's also a vector. Find the vectors that, so everyone has done k nearest neighbors, I assume, right? So it's basically a simple k nearest neighbors that you're returning from your vector database, and then you pass that as a context, and that should ideally be enough context to answer the question. So now, when we heard about vector databases helping with like answering these questions, right? The people making money in a gold rush is not the people hunting for gold, it's always the people selling shovels. So immediately you had like a whole bunch of old and new folks, some old folks rebranding themselves as vector databases, some new folks coming in as vector databases, some people pivoting entirely into vector databases, and so on. Some of these listed below, some of them you might have heard of, Milmus, Vespa, VV8, Quadrant. Pinecone is a hosted version, and so on, right? Your Chroma, again, an open source app. So you kind of have a bunch of these vector databases where you can just look at them as databases that make it easier to run, to like create your embeddings and then search through them, right? Create a vector embedding and search through them. So lots of cool stuff there, right? So now obviously you must be asking which is the vector database that I recommend to people, right? So we actually have played around with some of these databases. VV8, Quadrant, Milvus. Since we are at a DevOps conference, all of them are a Helm install away. So if you have a Kubernetes cluster, it's very simple to like set these up. The nice bit about like VV8 is that it actually supports things like custom index types, right? So even if you want to write your own index type, you can actually write your own index type and load it into VV8. But personally, I think like Milvus is really great because out of the box, I think it offers a lot of CN defaults, which I think is very useful for all of us in the ops dev space, right? Because you don't want to spend time setting up your database. All of these, again, because they are databases that are targeted towards vector databases, they do sharding slightly differently, but you can shard. They do like querying slightly differently, but you can query whatever documents you want. Their performance is also sometimes comparable, sometimes not comparable, where depending on a use case, you like pick and choose some of these. And Milvus also has a Kubernetes operator. So if you prefer having an operator workflow and you set up an operator in your cluster and then just create a Milvus cluster based off of that, that also works great. So yeah, like we have all of these great vector DB options, but end of the day, yeah, my all-time favorite database is Postgres. I have a huge crush on Postgres, and the reason why I like Postgres is, like I say, it's the Python of the database world, right? In the sense that it may not be the best at everything, but it's the second best at nearly everything, right? You can do almost everything with it, and nothing beats the ability, the power to like be able to run your existing databases, add a column with a specific type, with a vector type, be able to run your existing queries, your normal relational schema queries, and also like be able to do vector search on top of it. And it's great to have like one stack to fit it all. And I think yesterday Anuvrat did a talk where he spoke about like having one stack for everything, right? It really reduces the amount of things that you need to manage, and it makes life easier overall. So again, Kubernetes, if you run Kubernetes, if you run Bitnami or Cloud Native PG, setting up PG Vector, which is like an extension for Postgres that allows you to like have vector capabilities, it's literally 5 lines of code, right? And I think the 050 is like from last week. It's last week's release. So you're like more or less state-of-the-art PG vector setup. You'll have with 5 lines of code, run a sidecar. You run it once, enable the extension, and you can start working with it, right? Now, the way that vector databases work by default is they do perfect recall, right? Because they do k nearest neighbors. Now, k nearest neighbors, for people who know, it's kind of a perfect algorithm, right? Because it's going to, if you have one point, it's going to give you always the 5 points that are closest to it, or the n points that are closest to it. But the problem with that, and which has always been a problem with k nearest neighbors, is they're very slow, right? So we start on about indexes. And there's this pretty standard index at this point. It's called HNSW. HNSW is hierarchical navigable small worlds, right? And again, if anyone who's a data structures fan, right, HNSW is like a great read on how it actually works internally. So it uses data structure. If you have used this data structure skip lists, right, which are like more probabilistic data structures, what it does is it creates like multiple layered worlds on top of each other, and then you search within the world that you are in. And you can like actually navigate between different layers of this. So again, just like you do with binary search, because you're not searching the entire search space, it is actually much, much, much faster as well. So yeah, for lots of use cases that people are working on, LLMs, I definitely suggest like, if it works, makes sense for you, right? Maybe a couple million records if you're looking at, there is absolutely no reason for you to actually go the way of having an entire full-fledged vector database. Postgres, PG vector, HNSW will work great for you. So then we come to the agents. Now, the agents is the next step of it, where basically you had like RAG, which is like data that is in a database, but now with agents, what you're trying to do is like add some reasoning capabilities onto your application, right? So I'm sure everyone here has heard of LangChain by now. LangChain kind of came out of this paper that was called React, and we'll look a little bit at that model in the next slide. And what this kind of allows you to do is like have agents that have specific capabilities, right? So for example, you can say that, hey, like one of the things is you have a calculator, or you have access to Google, or you have access to some other tool, or I have access to my internal database. And then you build out these agents that are like able to perform these individual tasks, and then put them together along with an OpenAI API layer. So there's a lot more business logic that's happening. There's a lot more stuff that's happening within your application. And the OpenAI API is kind of like doing some sort of reasoning on top of it, all right? And very early on, when we started talking about like agents, there were like two great projects. One was called Baby AGI and AutoGPT. And they use this model called React, right? React stands for Reason and Act, which is, again, a paper that was published sometime last year or year before last. And you can see like what happens, right? The user basically at the right gives it a task and an objective. And there's like multiple agents that are there. There's an execution agent, a task agent, a prioritization agent, and there's a task queue and there's a memory. And all that's happening is, if you see, every 3 of these agents actually use GPT-4 behind the scenes. And they're coming up with like results that are going to be fed back into the task queue until the task is quote unquote accomplished, right? With some level of accomplishment. Now, these are really, they make really nice demos, and it's really nice to show. But if you notice, there are like multiple people making OpenAPI calls, which means that it can also prove to be quite expensive over time, right? Like a single task that you provide at the right can actually end up making not just 3 GPT-4 calls, but it can actually make way more GPT calls than, because it kind of goes in a loop, right? So it can work out quite expensive as well. So now, yeah, we've spoken about all these, but the common thing has been in all of these, we've been using OpenAI as our end goal, right? But there are cases where like OpenAI is absolutely a no-go. If you're in a health tech company, for example, or you have fintech regulations, if you have data residency requirements, then you can't really send your data out to OpenAI, even if you're using RAG or something like that. The fine-tuned models is one more example, where if you have enough data, or you have enough data that like suits your use case, and you feel that you're comfortable enough fine-tuning a model to your use case, that also works. Instead of like having RAG-based workflows, you can just query the model that's been trained on your data. And then the final thing is pricing. Like I mentioned in the previous slide, using OpenAI can be expensive, but I've added a question mark, and I'll come to that at the end of the presentation. So yeah, this is kind of what our end goal is. We want to get a private LLM within our network. And the first step for that is obviously going and begging who your service representative is to give you GPU compute, right? Your G-series machines, your N-series machines on Azure, any of these machines, because yeah, you're gonna have it's a fun time. I'll just say it's a fun time to like try to get GPU compute right now. So next we come to training, right? Training is, we have like a bunch of options. I won't really dig too much into this because yeah, like all of this has nothing to do with like Kubernetes in any way or with this, or with DevOps either, right? A lot of this stuff is like this. You have like a bunch of tools that you can use for fine-tuning a model. So you basically take a foundational model. OpenAI itself provides fine-tuning as well, but you still have to, then your API endpoint will be OpenAI. You have Hugging Face Auto Train, Google Colab can do that. You can do it with SageMaker as well. And two tools that you'll more or less almost always end up seeing if you like start playing around with like any sort of LLM-based app is like Ray and Llama Index, right? You'll kind of always keep following across them. And they kind of are like Swiss knives, right? They do a lot of things and do a lot of things well as well. So yeah, again, tools to like check out. So now let's deploy, right? Deployments, again, for our personal use cases, we use Kubernetes as a deployment environment simply because when we launch a stack for a customer, we already have a Kubernetes cluster that's there. So it kind of makes it easier to get like another node pool with like GPU instances there and then just host our data there, right? Host our model there. There's lots of ways to do this. You have tools like Ray, like I mentioned in the previous slide, K8s, which was KF serving before, and you also have like a little more DIY tools with a lot more control, like Gradio, where you're kind of getting a little bit in the thicket, right, and like actually working with like some of the stuff around deployments. But personally, I really like the OpenLLM BentoML way of packaging LLMs, and I don't know if it's visible there, but it's basically just two commands, right? You have a build, you build a model using OpenLLM, and then you have BentoML, which like, and you just Dockerize it, right? And once you Dockerize it, yeah, you Dockerize it, and hopefully this is visible, but yeah, it's literally just a Kubernetes deployment, well, along with a Kubernetes service. You have a deployment, so you can give it a number of replicas. So once you have a number of replicas, you can actually scale out quite a bit. If you want, you can add like some node affinity, all that fancy stuff that people do, and then yeah. So now obviously, once you have a model like this that is running with like a personal, with your private LLM that is running within your cluster, the next important thing is obviously scale. Scaling, very, very easy right now because you have horizontal pod autoscaler and you set up like autoscaling groups and you're good to go. For horizontal pod autoscaler, if you're using LLM here, you obviously, the primary thing that you're looking at is going to be your GPU usage, right? So there's something called DCGM exporter. So DCGM exporter is, NVIDIA provides something called a data center GPU manager, which is doing stats of your GPU, right? How much memory is being utilized, how much load the GPU is under, how much, basically, yeah, all these GPU related stats. So what you can do is you just set up DCGM exporter, which pulls these stats, and technically it's meant to like pull these stats and push them to Prometheus. It's a Prometheus script target. But if you have Prometheus adapter, you can actually like run HPA using the DCGM exporter stats directly. So yeah, again, like with this model, it kind of makes it very, very easy for you to like build, deploy, build your own. Once you have a trained model, to deploy your own model within your cluster. Scaling it is also easier, and like usually, yeah, that's kind of where you'll end up at. So yeah, for folks who are like looking to get up and running locally, right, with like some of these LLMs, again, one of my favorite tools in recent times has been Olama. Olama, again, the nice thing that they're doing is they're providing pre-Dockerized images for most foundational models, right? So you have like Llama 2, Code Llama, a bunch of other models. You literally, if you have a powerful enough MacBook, you can like actually run some of these models on your MacBook, right? If you have a MacBook Pro, an M2 Pro or something like that, Pro Ultra. The other thing that lots of people do, which I'm personally not a fan of, is like quantizing, where they take a big model and then they take a 16, all of these numbers are 16-bit floats, right, in parameters, and they convert it to an 8-bit float or a 4-bit float. And they like bring down to make it a smaller sized model so they can run in your machine. But the problem with like quantizing is that the loss of like quality is like quite drastic usually. So yeah, I usually prefer like if you can afford it, you always like try to get a bigger machine or like try to run it on a GPU rather than like trying to quantize and do all of these tricks. They're good for some use cases, but yeah, like by and large, our use case we have seen them not be particularly great. And yeah, now obviously observability comes in as the next step. So some of the things that we track, which obviously you need to track as well, is things like number of tokens, the latency that you have, and other server requirements. The quality, that's again a big thing, and if you've noticed, everyone from OpenAI to Claude actually has this thumbs up, thumbs down kind of thing, because they're basically trying to capture what the quality of the answers that are given is. Obviously, additional product analytics, you have A/B, if you want to run A/B between like different models, if you want to run a canary rollout, if you want to do some of these things, it's slightly more involved. And then you have feedback for retraining, right? Like RLHF, which is reinforcement learning human feedback. Where RLHF, it's a way in which we can fine-tune models based on human feedback, right? And just to give an example of this, everyone knows this model called Llama, I assume, right? Which is, sorry, there was a model called, yeah, Llama that came out from Meta. And some folks at Stanford, what they did was they came out with a whole bunch of data, and they tried to train a generic Llama model to be able to write code, right? And I actually have, this is the actual data set that they used, right? So for example, they say like create an array of length 5 which contains all even numbers, and they come up with the answer. And they say like formulate an equation to calculate the height, blah, blah, blah. So they give it like a bunch of data, and yeah, you can just go through this, and it's all code-related data. And what they do is they fine-tune the Llama model into something called Alpaca, and this is code Alpaca specifically, where it's a model that is fine-tuned to write code, right? And if you see like the data that they use is actually relatively small. It's like 20,000 examples that they've used. Another model that they trained used about 50,000 examples. Still compared to like the billions of data points that was used to train Llama in the first place, it's like much, 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 much smaller and much more doable for a lot of people. So yeah, this feedback is again something that's quite useful. So now, should you do this, right? Again, like I said, it depends on a lot of different cases. Whether, like, it depends on like what you're trying to achieve exactly, right? If you're like just trying to do it as an LLM app which is not core to your system in any way, I'd honestly suggest it's probably overkill for you right now. And the reasons, there are lots of reasons. One is the pricing that I spoke about, right? There's enough data around that kind of makes it seem that while OpenAI may seem expensive, running your own LLMs is just as expensive, if not more, right? And along with that, you're also taking in the load of actually having developers or ops people maintaining that LLM and growing that LLM and training and retraining and all that stuff, right? And that is kind of also adds to the cost. So there was this talk that came up recently, I think just a few days back on Hacker News, which kind of powers a lot of this, which talks about how OpenAI is currently working at a loss. And even with that, we consider it expensive. But if you run it yourself, you realize that OpenAI is still relatively probably your best bet right now. So what's next, right? We play with more foundational models, and the most exciting one for me is like Mistral that's come out a while back. We have like fine-tuning models that's in progress. We have agents and ensembles. Evaluation frameworks, which again very important when you have an LLM application, you obviously want to have some way to evaluate whether your model is better than the previous one or worse or how it compares, which is again a huge open problem. Internally, we have built a joke of we actually use an Excel spreadsheet to like track some of this stuff. We definitely need to get better at that. And the last bit is, yeah, definitely make more money than we spend on GenAI. Yeah, I explicitly asked by my CFO to add this because we've just been spending money right now and not really generating too much out of it so far. So, but yeah, it's been cool. So, is there a final slide? But before I wrap up, I'll just do a quick demo, if we can. So, yeah, this is our home dashboard. I have Aiden here, and I have 2 minutes here. So, let's see. Okay, so just to give context, here I have a pod that I created. Very, very straightforward. You can see what it does is it's a pod. It has an init container. The init container is trying to connect to Postgres blah blah. Postgres blah blah doesn't exist, right? So if I do get pods, then you'll actually see it's in a crash loop back off state, right? Now, I think yesterday the ZenDuty folks over here, they kind of spoke about how it's hard for them to build out GenAI because they're not integrated into the system of their customers, right? And they kind of get information late. That's not a problem for us, right? We are actually integrated into the observability system of any customer, and this cluster that I'm showing right now actually has Observe Now running on it, right? So let's ask a very simple question. I hate doing live demos because I never know what's going to happen. But fingers crossed, let's see. Oh, yeah, okay. It looks like it's actually picking things up here. So it says there's a pod called test pod that's unable to initialize, and it says you can check logs here. If I go into my logs, it actually goes to my Grafana, right? Okay, I have 50 seconds, so I'll just wrap up. So it goes to my Grafana, and it's actually going to pick up logs for my pod that I've mentioned. That I don't think it'll be able to know because it doesn't have info. It has info on my pods right now, and this is something that we're rolling out slowly, right? Okay, it says it's unable to initialize, but I don't. Yeah, technically, in some cases, it should give me more details, like it's not able to connect to my Postgres, and it just gave me logs right now. But yeah, like this is kind of what we are slowly building out, and this is like very, very beta right now. We have an explicit beta everywhere wherever we talk about it, because what we're trying to do is like just see how well it can work for use cases where it's integrated within your system. Things like, yeah, if I have an application, build a Docker file, build a alert, build a, like all these kind of use cases, right, which are like specific to DevOps, which all of us as DevOps engineers, we keep doing on a daily basis. It kind of makes life a little bit easier. So that's kind of what we're looking at. And then the final thing that we have is like also have the ability to write code, right? And to write code, there's this one thing that if you have some time, you should check out. It's called Sweep. They call it an AI-powered junior developer for small features, where all it's kind of trying to do is like come up with, like be able to like create PRs based on the data that is there, right? Now, again, with like OpsSource, because you have it integrated into your GitHub, you kind of have access to all your Git code. So technically, if I say like, oh, increase the resources for this pod, it should be able to like go into your Git and like make that change and raise a PR for you, right? We're not there yet, but yeah, it's something that we're building out right now. But yeah, that's all that I had. Thank you so much.
How many resources is it actually using for running the LLM model?
So for us, the way that we do it is we have taken the 24 gig G5 GPU models and we run them as run them as three replicas. We have run it as three replicas that is run, and these were our shared clusters that we have. So yeah, so it's like this is one more thing, right? When people talk about Kubernetes, and we probably should have touched upon it a little bit more on like why not, right? If I'm running a LLM, I kind of tie it to the way we run it, at least, is we tie it to like one pod per node, right? And we have like 3 models that are running, so each of them is using like a 24 gig GPU. So that's the resource utilization. Yeah, we're probably over-provisioned a little bit for our use cases right now, and yeah, we already have HPA and all set up. I don't think we've ever actually auto-scaled, right? Because that's been like more than enough for us so far. But yeah, it's again, you hope to scale, right? So.
Awesome. So since we are running late, so we are not going to
Thank
take
you.
questions, and you can always catch up with Navin.